Let's videotape this. Mr. G Math coming at you live, right? 7202. Lesson 7.5. Can you differentiate logarithmic functions? That's the focus. So we can find the derivative of the natural log function by using the formula for the derivative of inverse functions. And the reason is exponentials and logarithms are inverses, right? And we already had a unit on how do you do the derivative of an inverse, right? They're connected. So how do you do that again? Do you see this? This means the reciprocal, right? So that's how they're connected. So if f and g are inverses, the derivatives are inverses. So y equals e to the x and y equals ln x are what again? If f at x equals e to the x, then the inverse of e to the x is ln. You following? So the derivative of e to the x is e to the x. So the derivative of ln x, right, would be 1 over, now you got to make sure the x and y, right, have been flipped around. So what's the derivative of ln x? So in other words, the y coordinate here is ln x. You plug that back into where x is up here, right? So the y, g at x is a fancy way of saying y, right? The y would be plugged back into the x, because that's what inverse means, right? X and y. So you plug it back in. So instead of x, we have ln x. And then one of the properties of e to the ln x is just, it simplifies to what? Right? It simplifies to just x. So, in other words, when you take the derivative of ln x, the answer is, so it was a long journey to tell you, the answer is 1 over x. But it was the connection of inverses, right, in the derivative. So what's the derivative of ln x? And the answer is 1 over x. Now, if you have a hook involved, then it's 1 over x times whatever that hook is. Because these are going to deal with fractions, the hook is going to be in the numerator. I'm going to tell you again. Because these are fractions, the hook is going to be in the numerator. Because when you multiply a fraction, it's the tops. They get multiplied together. So where do you look for the hook for these? In the numerator. Are you with me yet? Yeah. All of these derivatives involve fractions. So if there's hooks involved, you're going to look in the numerator. Got it? All right. Now, most of the time we want to deal with ln because it's so easier, right? Yeah. Just like for e to the x, we want to deal with e to the x and not some other base. So we want to deal with the base of e. But if a logarithm doesn't have a base of e, it has another base. It's going to be 1 over, remember what ln was again? Was 1 over x, but what extra does it need in the denominator? Ln of whatever the base is. So do you see that there's a similarity between the two? So when you try to memorize those formulas, both of them start with 1 over x, but if it has a base other than e, you need ln of whatever that base is. And again, the numerator is going to be your what? Right, we're almost there. You ready? All right, that's okay. I'm here to be your monster drink right now. Let's do this. How do I take the derivative of 1? That's an awful analogy. I don't want to be your monster. Disgusting. Too much sugar. Bad for you. Bad for everything. All right, here we go. Why not eat properly, get your rest, and then you don't need that stuff, right? That's what I am for you. I'm not your monster drink. I'm eat right, get your sleep, right? Do it the right way. That's what Mr. Gerson is for you. So, here we go. How do you take the derivative of ln? No, so 1 over 5x. It's not reciprocal. It's 1 over, right, whatever it is. Times. And more we do this, you'll recognize the numerator is the... But, since you're not talking back to me, now I got to keep doing it in 2 steps. So, you are so right there. So the derivative of 5x is 5. That is 5 over 5x. That is 1 over x. Thank you. I like that wow. Hey, where does the hook go? Hey, let's do this now because you are listening to me. So, it's going to be the hook, 3t squared minus t is 6t subtract 1. That goes where again? And then the denominator? Done. Why is there no candy at the end? Because you're deriving, right? Just in case your heads get all scratchy like that, like, oh, where's the plus c or whatever, right? Not that you would ever do that. All right, what's the derivative here? X times ln x. How do I take the derivative? What's that? X times ln x. I want someone to recognize that, wait a second, this one's different. I have to use the product rule. You have two things multiplying, correct? X times ln x. That's the product rule. If the x in front was just a constant, then you're not multiplying the, two with variables. That's the product rule. What is the product rule? Times the plus times the, got it? And then we could simplify this. And the answer is 1 plus ln x. Can you see how I did that extra step there? We practice simplifying for multiple choice questions. Any thoughts? Okay. Keep going. Example 4. Y equals the absolute value of x in the coordinate plane at the right. Do you remember how to graph this? Because Miss Gardenia helped us with the review, right? How do we graph something like this? When the absolute value is inside, right? The logarithm, what's it going to look like? Well, we have intercept at 1, 0. The second point, the base you don't see is e, which is about 2.7 and 1. So approximate where you think 2.7 and 1 is. And we have an asymptote over 0. But what's it going to look like on the left side? That absolute value makes all the numbers other than 0 valid. So on the other side, what would it be? So it says, for the right half of the graph, right? The absolute value really has no effect, right? Because a positive number just stays positive. So when it's greater than or equal, the answer would just be 1 over x. But what happens to the left side over on this side? And it says plot some points and then think about what the derivative would be on the left side. So on the right side, let's start there still. Do you see 1, 0? If I asked you, what's the derivative of this? You would say, oh, the derivative of that is 1 over x. When you plug in positive 1, what's the answer to the derivative at 1? 1. What happens over here at negative 1, 0? What do you think the derivative is here? Not the inverse. What would happen, right? And the two obvious ones to look at are, is it going to be negative 1 over x? Or is it going to be the same, positive 1 over x? Does that make sense? It's going to be one or the other. Either on the left side, it's going to make it negative 1 over x, or on the left side, it's going to stay positive 1 over x. Because it's the same curve, right, on both sides? Just been reflected. So what happens if I take that point there and do the same thing? If I plug in, now by the way, what is this slope here? Negative. Right? Can you see that? So if I plug negative 1 into x over here, what answer would that give you? Can you see a negative divided by a negative would give me positive? So it's not negative 1 over x. Instead, what is it? So in other words, whether it's on the left or the right, the derivative stayed the same. So those absolute value inside doesn't change what the derivative is. It's having an understanding of why that's the case. That's what it's looking at. So when differentiating that ln x or that ln u, the absolute value can be ignored. In these cases, absolute value may change the domain, but not the derivative. So what's the derivative for y equals ln x? And the answer is the derivative is 1 over x. How about for ln the absolute value of that? What's the derivative? The same thing, 1 over x. That's the property lesson there. All right, turn the page. Can you take the derivative of that? So when you see the bars inside, you now know why it's the same as if the bars weren't there. Yes? So what's the derivative? What goes in the numerator? No, what goes in the numerator? What goes in the numerator? The hook. If you go back in the video, you should count how many times I've had to say that to you. So what goes in the numerator this time? Negative 6y squared, because the derivative of 5 is 0. And then what goes in the denominator? Done.
Does the absolute value come down with it, or just inside of it?
No. So the whole point is whether the bars are there or not, the deriving is exactly the same. Now, when we integrate back, we're going to have to learn to do something with those bars, but that's for the next lesson. This lesson is the bars inside or not the bars, it still derives the same way. Yes? Okay, example 6. It says, when possible, simplify the logarithm before you start deriving, right? That goes back to one of my main principles of calculus, right? Do the algebra before the calculus, right? To make life easier. Okay, so first, how can I rewrite this so I can take the derivative easier? So, I'm going to tell you a few things. First of all, when I see a radical sign, I've already learned that that's going to be 2x plus 1 to the 1/2. Normally what I would tell you is if I see a fraction that you start using negative exponents, right? But I'm not telling you that in this case. In this case, what I'm telling you is now we have to use properties of logarithms to simplify it. So normally I would say if you see a fraction, write it as a negative exponent. But in this case, I'm saying it's a logarithm. There are properties to use here. So I'm going to write this underneath so I have a little more room. So if I want to write this and I want to expand it, what would I do? So I'm going to start. When I see multiplying, what do? Add. This is still what y equals. I have not taken the derivative yet. And what am I multiplying? 2x plus 1 to what exponent? Where can the exponent go for properties? In front. Notice if there's adding inside a logarithm, you let it go. There's no properties that's going to expand that. Did you hear what I said? When you see adding or subtracting inside a logarithm, you got to let it go. It's multiplying or dividing inside. And then when you see dividing, what do you do? And what are you subtracting? And again, do you see the adding in there? And that exponent can't go in front because it belongs to the 1. All right. Now, how would you take the derivative? So sometimes you got to use properties of logarithms. Now you can take the derivative. So what's the derivative of ln x? 1 over x. What's the derivative of 1/2 ln 2x plus 1? What goes in the numerator? What goes in the numerator? 2. Thank you. And then what goes in the denominator? Keep going. What goes in the numerator? 2x, right? And then what goes in the denominator? Done. And if you wanted to, the 2's could simplify here, right? And you could just write it as 1 over 2x plus 1. But can you see the big point is sometimes you have to use properties of logarithms before you start deriving. All right. It says use the change of base formula to show the derivative of this is equal to that as a formula. So to do that, recognize that log x base a, the change of base formula allows you to change it to any base you need to by dividing. So, in this case, what is the base for calculus? E. That logarithm would be which one? That has a base of e. Ln. So this means the same as ln x divided by ln a, where a is a constant. You could do that with any logarithm. You can take any. Normally we do this using a common logarithm. That'd be an empty base. That'd be log x divided. It's also equal to this. But for calculus, to change it to log x divided by log a is not as helpful. We want a base of e. So if I'm taking the derivative of that, ln x over ln a, how would you do that? I wouldn't subtract necessarily. Do you know that a is a constant, right? So it's just the same as saying like 1/2 in front or something like that. So let me rewrite it like this so that you can see 1 over ln a is just a number. It could be 1 over 2, right? So when you take the derivative, do I need to worry about 1 over ln a? That's just part of that derivative, right? 1 over ln a. What's the derivative of ln x? And then when I put it together, what do you have? Ln a times x, or x times ln a, right? Does it equal what the formula is? Yes. Yes. Do you really care where it comes from? No, but I'm still given sometimes, right? I care more that you can apply it, but it's nice to see where it comes from. Example 8. Can you find the derivative at 2? So first, what's the derivative? What's the numerator? Yay! What's the denominator? So it's x squared plus 1. That's what it would be if it said ln that, right? So what do I need to, because the base is not e, what does it need still? Ln 2, right? Whatever the base is. Then that's the derivative. Now what do you plug in for x? So wherever there's an x, plug in 2. You could make it look a little prettier with a 4 on top. 2 squared plus 1 is, and it's done. That's it. Taking derivatives with logarithms.